My name is Jessan, and I am a Master of Engineering and AI student from UP Diliman, and I'm presenting SpeechX, enhancing the robustness of speech foundation models through adaptation on large-scale diverse speech. So to understand SpeechX, we must first understand large language models. So tokenization is an important pre-processing step for training large language models. So for example, here the sentence, "It is raining." This sentence can be partitioned into characters, as shown in the first row, or by word, as shown here in the second row, or by subword, which is a compromise between character level and word level tokenizations. So it is important to note that the tokenization process is completely reversible. So it means that if you encode a string into token IDs, you can decode the token IDs back to its text representation. So ChatGPT and other commonly known LLMs write essays, answer questions, or make recipes just by trying to generate the next token in the input sequence. For example, if you input the cat to the LLM, it will, for example, the output of the LLM is sat. The word sat is appended to the input prompt to generate the new prompt, the cat sat. And this process is iteratively performed until it reaches the end of text token. And this approach is called autoregressive language modeling. So we now proceed to SpeechGPT, which is the backbone model of SpeechX. So SpeechGPT is a foundation model, which is cross-modal. So it means that it can understand inputs and produce outputs in either text, speech, or both modalities. So here, it can perform text generation, it can perform speech-to-speech task, or text-to-speech, and lastly, automatic speech recognition. So how does SpeechGPT, which is a LLM-based model, do this? So the key here is that the conversion of speech recordings to a representation that LLMs can understand. So the example here is for the ASR task. So the speech recording is passed onto the HuBERT tokenizer to generate the discrete codes. And these discrete codes consist of integer tokens wrapped by start and end of speech tokens. So this discrete code is appended to the input instruction, and the concatenated sequence is passed to the cross-modal instruction generator, and the final instruction is fed to the LLM to generate the transcription. So the training process of SpeechGPT consists of 3 stages. So the first one is modality adaptation, which is also called pre-training. So the model is pre-trained on pure speech tokens. So the dataset used here is Libri-Light dataset. So for the second stage, it is cross-modal instructions. So in cross-modal instructions, the model was fine-tuned on ASR and text-to-speech instructions using LibriSpeech, GigaSpeech, Common Voice, and MOS002 SFT dataset. And lastly, for the third stage, chain of modality instructions, the model was fine-tuned to discourage illegal, obscene, or toxic responses using the MOS002 SFT dataset. And the main issue here is that SpeechGPT was pre-trained exclusively on Libri-Light, which is a dataset consisting of narrated speech recordings. So the problem here is that it may not perform well on speech recordings on other speaking styles. So to address the problem, we further trained SpeechGPT on a diverse collection of speech datasets based on the end-to-end speech benchmark, as shown here in the table. So these are the 4 datasets. So the first one is LibriSpeech. It consists of narrated audiobooks. The second one is VoxPopuli, which consists of oratory speeches. Third one is GigaSpeech, which consists of audiobooks, podcasts, and YouTube videos. And lastly, SPGISpeech, which consists of recordings of financial meetings. So the total number of hours is 16,000 plus hours. And this is to cover a wide spectrum of speaking domains, acoustic environments, and speaker characteristics. So to develop SpeechX, we add GigaSpeech, VoxPopuli, SPGISpeech, and LibriSpeech to the modality adaptation stage, and VoxPopuli and SPGISpeech for the cross-modal instruction stage. Lastly, we do not fine-tune further the model for the chain of modality instructions. We evaluate SpeechX on the automatic speech recognition task using the word error rate. So word error rate, or WER, is computed using the sum of insertions, deletions, substitutions, all over the number of total words. So here in the example, the number of insertions is 1 since now was included to the ground truth. The number of deletions is 1 since the word the was omitted. And the number of substitutions is 1 since the word bark was replaced with bark, obtaining a word error rate of 0.5 or 50%. So we evaluate the model on each dataset using the Hugging Face Evaluate library. So we noticed that for the LibriSpeech dataset, we obtained 76.7% improvement. For VoxPopuli, it is 52.6%. For GigaSpeech, it is 59.3%. And for SPGISpeech, it is 80.8%. So I'm showing you a demo of the automatic speech recognition task that SpeechX can perform. So the ground truth, the ground truth here is the string, what are the main causes of climate change? So this is the demo for the ASR task. So the model will transcribe a speech recording.
What are the main causes of climate change?
So SpeechX correctly transcribed the speech recording input. So the next demo is text-to-speech. So here the model was prompted to generate speech from a transcription.
May the force be with you.
So it can also accurately perform text-to-speech tasks. And lastly, it can perform language tasks such as question answering. So to conclude, since SpeechX can perform a variety of speech-language tasks, we highlight its potential to advance the reliability and inclusivity of speech foundation models. However, one of the limitations is that it may not be representative of the performance of small language models, such as Phi-3 and Tiny Llama, since the fine-tuning was performed on a 7 billion parameter SpeechGPT model. And also, the focus of this project is on English datasets, which may limit the generalizability of findings to other languages, such as Filipino, Spanish, or French. So that's all. Thank you po.
Thank you, Sir Jessan. I think we have time for one question from the audience. Anyone? Yes.
So hello. If I'm not mistaken, your presentation is all about further fine-tuning SpeechGPT using other various datasets on some of its SpeechGPT's stages. How were you able to determine which dataset goes to which stage? Were there any rules or that you considered, and like was it the size of the dataset and so on and so forth?
So thank you for that question. So the rule that I used is if the dataset in the original training is not included here in the proposed list of fine-tuning datasets, the datasets here will be included for the fine-tuning for the development of SpeechX. So for example, this so for example, in the second stage, VoxPopuli and SPGISpeech were not included in the original training stage. So we included it for the development of SpeechX. So that's all. Thank you po.
Thank you, Sir Jessan. So now let me present to you your Certificate of Appreciation. Certificate of Appreciation is presented to Sir Jessan Rendell Belenzo for sharing their invaluable insight on work on enhancing the robustness of speech foundation models through adaptation on large-scale diverse speech during the NEECE Con 2024, given this 19th day of July 2024 at Novotel, Manila, Araneta City, Quezon City, Philippines, signed Dr. Lou Andrew Tria.